Hello, today I'm going to show you how to unpack and install the Mutech Microsystems microlaser. First I'm going to show you this crate. This is the crate we ship. I'm going to show you how we unpack this. Then we remove the machine from the crate. Then we are going to connect the machine to the computer. We are going to unpack the machine. We are going to remove all the immobilizers, all the packing material. And then we are going to do the laser calibration. So first, let's just okay. And here we come in with plastic wrap for water protection. Things like this. Then we have to remove the screws. Okay. Here we have the user manual with the quick starter guide that I heavily recommend to read before doing anything. It describes the whole installation procedure that I'm showing you here, but please read it. Then we remove packing material. A box with accessories. Then we can proceed to lift the machine. Like this. Hold it. Okay. Pause. Okay, now we are going to remove the packing material from the machine. Carefully so we don't damage the machine. All over. Okay. I'm going to remove the stretch from the machine. Now we can see here. Focus here. We can see here there are two big immobilizers that it says remove me. Okay, and we have to remove. Quite simple, just like that, just like this. And the other one. These are shipping immobilizers. Save them if you have to move the machine later, but we need to remove them so it looks like this when it's clean. We can put back the lid now. Or remove it. Okay, now we have the machine fully unpacked. We're gonna start testing the. Okay, now we have the machine fully unpacked. I'm gonna show you how to test the machine when you receive it and how to start it for installation basically. The first thing we have to do is to remove the C-trace on the camera cable, which is the one which goes to the cable bundle here. We plug this to the computer. We have to have the computer already set up with our software already installed. Okay, the software needs to have some folder, right, with the configuration files, as I showed you before in an email. So we start up the software. Okay. We're going to connect the camera to one of the computer USBs, and then from the accessory box we have the USB cable, which we have to connect to the computer as well, and behind the box, the electronic box. Okay? Like this. Plug it. And power. This is just an interlock, a regular computer power cable. We plug it into the machine. And now we turn the machine on. From here, you should hear the fan ramping up. That's normal. Then on the software, we go here in the upper right to connection settings. We should see everything here, and there should be two serial ports. If you click in the information, we should see two serial devices, which are labeled as USB serial device or microlaser. Depends on the drivers. In this case, it comes 7, which appear when you connect the computer. And then on camera, we select USB 2.0 PC camera, which is the one that's on the machine, and it shows the resolution 640 by 480, which is typical resolution. Then we go up here, we click on the arrow next to the connect button and click connect without homing. Okay, this is for testing all the end stops and such when we receive the machine. So we open here the machine controller, and we open this window, which is the machine controller. Okay, now what we are going to do is here in the machine, we're going to click each and every one of the end stops manually. First we click here, and we see the software. When we click it, this changes from O to C in the status bar. This means open and closed. This is the lead interlock. Then we click each end stop. This is the Y plus. We click here. We should see alarm, Y max hit. Okay, we click unlock alarm, and it should unlock. So it moves back. So I'm gonna do that again. I click here. I max hit. We click unlock alarm, and the stage should move in the other direction. Then we do the same with the other ones. This is Y min. It says and stop Y min hit. We click unlock alarm, and it should move in the other direction. And we click the alarm. Okay, now I'm gonna do it with the other ones. This X min, right? We click unlock alarm and it moves like this. And last, Y max, X max, we click it and stop X max hit, unlock alarm and moves. This is for testing all of the end stops. Okay, this is to make sure that everything is okay and all the alarms are triggered when they should. and then we can home the stages. Okay, by click home X first, and we see in the machine it's moving the stage. Okay, next, when we do this, we can put the hand in here just in case, and it homes the X stage. Then we home the Y stage, same. Okay, now both stages are homed. Okay, so yeah, the machine is basically working fine. That's how it should work. Okay, so okay. Hello. Okay, now that the machine is done, what we need to do now is to align the laser. To align the laser, first we of course need to connect to the machine in the software, the corresponding connect button. Then we're gonna put the platform in the middle. Basically, let's move it to 50-50, like this. Now, in the software, let's turn the laser on at maximum power. I'm gonna write here 255 and click Ctrl and Shift and turn the laser on with the button. This will override the lead interlock because we need to work on the laser without the lead. Okay. So now the laser is on at maximum power. We can see here that we see a bit of laser light, but it's misaligned. We should put a piece of paper. Maybe you don't see anything because this is misaligned, but you can see a bit. But maybe you don't see anything because it's more misaligned. So let's just now align it. We have two holes here in the top of the cover, and these holes correspond with two screws for rotating the tilt of the laser inside of the machine. And what we need to do is to align it with a pinhole that's inside the optics. For this we need a 2.5mm Allen key, and we will just put them through the holes. And we need to check here on the laser. Just put it as best as we can in the middle, so the spot looks centered. See, just like this. So check here. If I move, for example, the vertical one, we see it goes from one side to the other. We just leave it in the middle as best we can in both directions. Okay. Check here. This is left to right. We just leave it in the middle. Okay. So when it's in the middle and it looks symmetrical, now we put the 4x objective on the optics. Okay. This is the 4x objective. We remove the paper. Okay, and then in the software we're going to lower the power to around 180, like this. Okay, so now what we're going to do is in the software, let's open the camera just like this. Okay, the camera view, we should see the view through the objective. This is a piece of silicone, just a random piece of silicone, or you can use any reflective surface. We put it under the objective. Okay, so we get in the microscope in the camera the reflection. Now what you have to do is focus on the software, on the spot. Okay. With the 4x objective, the increments are relatively high, so in the order of 100 microns should be alright, until we get like a spot that looks more or less like this. Okay. We can use this crosser. It's just for reference. It doesn't do anything, but we can use it to know where the spot is, and we can put it in there. What we need to do now is to finish the alignment process, to do like a fine tuning of the alignment. So the spot looks fully symmetrical, the best we can. We are not looking for it to be round. What we are looking is to get maximum power and for it to be symmetrical, to look symmetrical mostly when you move it in and out of focus, it needs to grow, the spot in the camera needs to grow and shrink in a symmetrical way. I'm going to show it to you later. So now let's put the Allen key again. And now looking at the camera, one second. Okay, now we're going to finish the alignment. Looking at the camera here, we're going to put the Allen key back in the hole for calibration to move the spot. We can check, we can move the spot from one side to the other, okay? And we're going to leave it in the middle, basically. This is a finer adjustment than the one we did previously. Okay, in both directions, we can check in one direction and the other direction. Check. See how now it's much brighter. We were clearly not in the middle. What we want is maximum brightness, okay? So basically we move it in one direction and we see, okay, this is the maximum brightness. In the other direction, okay, this is maximum brightness, and you know, you might need to play a bit with both axes because, of course, if you are way too out of focus or too out of alignment, if you're out in both directions, you move in one axis, it's gonna be, you're not gonna have any image in the other. So now it looks like you have maximum brightness. We can even lower the brightness a bit so we can see a bit better the spot. We can check the shape, that it grows in a symmetrical way, more or less in a symmetrical way. This is what you are expected to see basically when it's aligned. And of course you need to make sure that you are in a condition where you get the maximum brightness, okay? Because if it's not in maximum brightness, then it's not going to write anything. You need to make sure that when you align the thing, the brightness of the spot is basically the maximum. And basically that's it. Now it's aligned.